Alright, this is section 3.2, linear functions. This section is ultimately a review from pre-algebra. What we're going to cover in this section is identifying linear functions using graphs, tables, and equations. So I'm going to give you a graph, a table, or equation, and I'm going to say, is it linear or nonlinear? And then graph linear functions using discrete and continuous data. So discrete versus continuous domains. So here we go. Discrete domain. A discrete domain is a set of input values. Again, if we're talking x and y coordinates, we're talking about x coordinates for the domain. And it consists of only certain values, and I've got that underlined because that is the key point right there for being a discrete domain. You have only certain values in a discrete domain. And then graphically, this would be a set of individual unconnected points. In contrast, we have a continuous domain. A continuous domain is a set of input values, again, x coordinates. Let's copy that from my last slide here. A set of x coordinates. Since it is a domain, it is x coordinates. That consists of all values in an interval. So there's the keyword there, all values in an interval. So if it's continuous, you've got all the values, which graphically this would be a line segment, a curve, etc. So that is different than having only unconnected individual points with the discrete domain. If it's continuous, you have all the values from some number up to another number. All right, so this example, again, domains are talking about x coordinates. So I'm going to put that on here one more time. The domain is talking about x coordinates. And in this one, we're looking at the smallest x coordinate and going up to the largest x coordinate. So the graph, this point right here has the coordinates -5 something. It doesn't even matter what the y coordinate is, but I'll put it on here, -5, -2. And it's going up to, this graph is connected all the way up to the point 1, 4. And again, that 4 doesn't play any part in this because we're just talking about a domain, the x coordinates. So what is the domain? Well, all the numbers, we have all the points in here. Every single one of these is a point, and all these points go all the way from -5 with their x coordinates up to 1 with their x coordinates. So in pre-algebra, I'm not going to make you write what's called a compound inequality. Instead, when I give you a continuous domain, instead of, so you might look in the back of the textbook and you might see this -5 is less than or equal to x is less than or equal to 1. I'm not going to make you do that in pre-algebra. What I am going to have you do though is, if it's a continuous domain, so this one is continuous because we have all the values from -5 to 1. When it says what is the domain, I'm going to just have you describe the domain. So it's all values. I'm going to type this one out here. The domain consists of all values from -5 to 1, and that is acceptable in pre-algebra. Just describe the domain values if it's continuous. All right, what is the domain of this one? Well, this one is a discrete domain because there are certain unconnected points, discrete domain. So there's individual points here. There is no line segment or line or curve. So in this one, we can actually list out the x coordinates. So the x coordinate to this point is -5. So I'm going to say the domain consists of the set of x coordinates -5. This point here has an x coordinate of -2. This one has a +1 x coordinate, and the last one here is +4. So I'm going in numerical order. That means least to greatest. And I'm listing out the x coordinates because it is a domain. And this is the correct notation. So if you have a discrete domain, you should be writing your domain in this way. This means the domain is defined as the set, and then you list out the x coordinates there. All right, moving on. This part is about linear equations. So if I go back to my original slide here, what you're going to learn, identify linear functions. That is what this is about right here. So in this slide, a linear equation in two variables, that means if you have x and y, not just a single variable, like x = 7 is not two variables. So a linear equation in two variables, x and y, is an equation that can be written in this form, y = mx plus b. That's slope-intercept form. It says m and b are constants, just meaning they're numbers. The graph of a linear equation is a line. Likewise, a linear function is a function whose graph is a non-vertical line. So a linear equation is any equation that can be written in this form. A linear function has a constant rate of change, meaning a constant slope, and can be represented by a linear equation in two variables. A nonlinear function does not have a constant rate of change, so its graph is not a line. So if it's a curve, obviously it's nonlinear. But the main thing I'm going to have you look at here is this, what I highlighted in green. It can be written in the form y equals mx plus b if it's a linear equation, and it has a constant slope. Okay, so remember those two things. Can write it in slope-intercept form, has a constant slope if it's a linear equation. All right, so which of the following graphs is a non-linear function, and why? Well, obviously the one that it's non-linear is the one that's not a line. So this one's a curve, and this one's a line. So this one is definitely non-linear. On the right side, it's non-linear. On the left side, it is linear. So this one, it asks which one is non-linear. This one is non-linear. Again, I'm just going to type this out. This is nonlinear since its graph is not a line. And you could also explain that by saying since the slope is not constant. So either explanation, if I give you a graph, would be okay. On this one, I'm just going to say that it's nonlinear since it's not a line. Let's keep it simple. All right, so which of these represents a nonlinear function? Well, remember, a linear function has a constant slope. So we're just looking at which one of these does not have a constant slope, and that will tell us which one is nonlinear. Remember, to find a slope from a table, you're looking at the change in y over the change in x. In other words, the rise over the run. So the slope is rise over run, which means the rise is the change in your y coordinates. So change in y. The run is the change in the x coordinates. So divided by change in x. Change in x. All right, so what is the change in y in this first table? Well, you keep increasing by 4. We keep adding 4. And then what is the change in x? So you just keep adding 1 from one x coordinate to the next. So this has a constant slope of 4 over 1, or 4. So that one is linear because it has a constant slope. But the question ultimately asks us which one of these is non-linear. So it has to be this one if one of the two is nonlinear. Let's just double check it. So looking at the second table, the y coordinates are first increasing by 7, then decreasing by 7. So I could really stop there because x is increasing by 3 and increasing by 3 again. So that is not a constant slope. And again, it decreases by 7 and then increases by 3 here. So if I just had these three coordinates, then I could say, oh yeah, it's a constant slope going down by 7, going up by 3. However, it's first going up by 7 while it goes up by 3, and then down by 7 as it continues to go up by 3. So this one changes its slope. It starts as a positive slope and then has a negative slope. So this is definitely some kind of curve. All right, so this one, I'm going to say this one is nonlinear. And my reason is the slope. The slope is not constant. So the directions say which of the following tables represents a nonlinear function. That would be this one because it has a non-constant slope. All right, moving on. Which one of these represents a linear function? So in this one, I am going, if I go back to my original slide here, I am determining whether an equation is linear or nonlinear. So if an equation is linear, it can be written in the form y equals mx plus b in slope-intercept form. So which, if any of these, cannot be written in slope-intercept form? Well, I want to start with the obvious ones first. This one is y equals 4x plus negative 2. This is y equals mx plus b. So this one is linear because it can be written in slope-intercept form. Okay, you know what, I just keep trying to write with a mouse here. Let's save some time. And I can just copy and paste this later. So I'm going to say this one is linear since it can be written in slope-intercept form. And that's y equals mx plus b. All right, so moving on, are there any others on here that can be written in slope-intercept form? Well, this one right here, I could write this as y equals 0x plus 3.8, and that is y equals mx plus b. Y equals mx plus b. So again, this one is linear since it can be written in slope-intercept form. The other two, I cannot write in slope-intercept form. This one has a square root symbol. Y equals mx plus b has no square root symbols in it, so this one is nonlinear. This one is nonlinear since it cannot be written in slope-intercept form. And then this one, the last one, is also nonlinear. It has an x squared term in it. This is what's called quadratic. So there's no way to write an x squared, or there's no way to have an equation with an x squared in it that is linear. So it's not y equals mx plus b. The exponent on the x here is an invisible 1, not a 2. All right, so there you go. All right, example number 5. We just have 2 more to go here. This one is asking if it is a linear or nonlinear function. Well, this one, it says the table to the left shows the amount of money y of a credit card balance after x purchases. It does not matter what this scenario is. So that does not help us for this linear versus nonlinear. So on this one, it's just, does it have a constant slope? So I'm actually going to write that on here. i.e., does it have a constant slope? That's really what this question is getting at. It doesn't matter what the scenario is, just does this have a constant slope, yes or no? So if I look for the slope here, my change in y, I'm going down by 5, and that keeps happening from one to the next throughout the entire table. And for my x's, the change in x increases by 2. Every single one of these is increasing by 2. Therefore, it does have a constant slope. So this table represents a linear function since it has a constant slope. That's it. All right, and now for the last example in this section, it says, is the domain continuous or discrete? Well, now this does matter, so now I can't cross this out. Continuous versus discrete, if it's data with a scenario, you have to take the scenario into play. So remember, back in pre-algebra, we were talking about if you go to the store and buy a certain number of shirts, that is representing, and the amount of money you have left is represented in the table after you buy so many shirts. That's a discrete domain because you can't buy partial shirts. You can only buy whole numbers of shirts, so when you graph them, you graph individual points, you wouldn't connect them, right? So this one shows the height of a person that is X years old. Well, you don't teleport from one height up to the next. I shouldn't even say teleport. You don't jump from one height up to the next when you turn the next year old, right? So you don't just wake up on your birthday and go, hey, I'm half a foot taller. It doesn't work that way. You will gradually grow, and then when you're older, you'll gradually shrink, but you're not just going to jump from one height to the next. So with that in mind, if you were to graph your heights, you are going to want to connect those points. Because you want to connect those points, that is why it's going to be continuous. So what I'm going to say here is the domain is continuous since the graph would contain all values I'm going to say from, well, I can't really say from a certain number up to a certain number. I suppose I could say from your birth to your death, but that I suppose I could put that, since the graph will contain all values from your birth to, I'll just put to the present to keep it a little less morbid. There we go. So the domain is continuous since the graph would contain all values from your birth to the present. What I mean by that, i.e., it would make sense to connect the points. So it's not like we're buying shirts or belts at a store where you can't buy partial things. In this example, it makes sense to connect them. Another example that would be continuous, let's say you're finding the distance you've driven over X hours. You're not teleporting from one place to the next. It would make sense to, if you graph them, to connect those points, so that would be continuous as well. All right, so that is your lesson. So your homework here is pages 117 to 119, numbers 5 through 10, 17 through 24, and 29 through 32. Don't forget you have the online textbook now. So you go to online textbook, open it up, go down to Common Core High School, Algebra 1, and what pages did I just say? 117 to 119. So I'm going to go to 117 here, 117. All right, 117, and then your 5 through 10 problems, let's take a look at those real quick. It says determine whether the graph represents a linear or nonlinear function. That's just simply, is it visually a line or is it a curve of some type? Or does it change its slope like in number 9? If it's a line, it's linear. If it's not a line, it's nonlinear. Now it does say the word function. So you have to be considering, is it a non-vertical line? A vertical line does not pass that vertical line test that we talked about in class. So a vertical line is the only example of a line that is not considered a function. So it'd be a linear equation, but not a linear function. So in this example, it says a linear or nonlinear function, but they don't even put the example of a vertical line, so you don't have to worry about that. So if it's linear, if it's a line, it's linear. If it's a curve, it's nonlinear. Or if it changes its slope, it's nonlinear. And it does say explain, so please say because it has a constant slope, it's linear, or because the graph is a line, it's linear. All right, 17 through 24. 17 through 24, here it says determine whether the equation is linear or nonlinear. Again, can it be written in the form y equals mx plus b? Now, like on number 18, you can write this as y equals negative 3x plus 7. That's the same thing. If y equals negative 3x plus 7, that is y equals mx plus b. So number 18 would be linear because it can be written in slope-intercept form. So that's your answer for 18. Going on to 29 through 32. 29 through 32. So for 29 through 32, they are giving you these tables, and be careful, they give you units on all of these. And it says determine whether the domain is discrete or continuous. So bags and marbles, well, can you have partial marbles? Can you have 2.7 marbles in a bag? Well, no, not realistically. So this is going to be a discrete domain. So I'd say that for 29, this is a discrete domain because you can't have partial marbles. On 30, that's talking about the height of a tree over so many years. That's very similar to our problem. So I would say this explanation right here, except change it for the number of years and the height of a tree. 31 and 32 are very similar, so just keep thinking about is it possible to break down those units indefinitely. In other words, if you graph them, would you connect the points? If you wouldn't connect them, it's a discrete domain. If you would connect them, it's a continuous domain. All right, let me know if you have any questions. Thank you and have a great day.